To start with, let's get a better understanding of how far our closest neighbor is. And to gauge this, we can use the fastest space apparatus invented by humans, Helios 2, a satellite system dedicated to sun observation. Its speed is 157,000 miles per hour, which is about 0.023% of the speed of light. Rather impressive. The resources for colonization of the New World are packed, just waiting for the signal to launch. We're heading to the Alpha Centauri system. 3, 2, 1. Don't worry, there's nothing wrong with your internet connection. The picture really stays the same. Right now, we're moving faster than anything ever created by humans, but on the cosmic scale, we're practically standing still. We'll be able to reach the nearest star system only in about 18,000 years. That's the reality of things. Only when you realize the scale of these things can you understand how important it is to study our cosmic surroundings if we ever stand the chance to wake up and enjoy the sunshine from a different sun. The costs are too great to do this at random. That's why Alpha Centauri became one of the first star systems to be studied so closely. People noticed the main star, or more precisely a pair of stars, Alpha Centauri A and Alpha Centauri B. Both stars are sun-like yellow dwarf stars, which appear as a single star to the naked eye. The third brightest star in the night sky captivated the scientists' attention since prehistoric times, including the Summer civilization and the ancient Egyptians. It's even mentioned in the words of Ptolemy, but the systematic scientific study of the star system only started in 1915 when the British astronomer Robert Innes discovered the third star in Alpha Centauri, a red dwarf that was given the name Proxima Centauri. To this day, it remains the closest known star to the Sun. The open and detailed study of our nearest star happened at the same time as the start of the golden age of science fiction and space opera, which leads to a huge rise in popularity for Alpha Centauri. It has been and continues to appear in the works of sci-fi writers, artists, movie directors, and even music composers. The proximity of another star stirred the minds of creative people, from the Strugatsky brothers to James Cameron, because there in the different world under a different sun could reside and develop entirely new civilizations. And so Alpha Centauri forever earned its spot in people's mind as the place with the most potential of extraterrestrial life. However, the reality is much grimmer, as it often happens. The active study of exoplanets planted a new seed of hope, discovering a signal, or at least circumstantial evidence of life on faraway planets. Scientists found 2 planets in the habitable zone in the Alpha Centauri system, Centauri AB and Centauri BB. However, unfortunately, after a more detailed study, both planets turned out not to be habitable as we know it, and so astronomically speaking, these planets were temporarily shut down. But everything radically changed in 2016. After years of intensive search, the scientists managed to find and, more importantly, confirm the existence of an exoplanet in the Alpha Centauri system. What's more, this exoplanet rotates around our closest neighbor, Proxima Centauri. As such, the find was named Proxima Centauri B. The planet is approximately 4.22 light-years away, and it's incredible that it was discovered in the first place, because the planet's mass is only 1.1 times of the Earth's mass. It was a very lengthy and work-intensive process to confirm this existence, which was done by measuring the radial velocity of the planet as it passed across the disk of its parent star, Proxima. But the surprises don't end there. Proxima Centauri B had more surprises in store for researchers. In April and May of 2019, Parkes Observatory in Australia recorded strange radio signals over the course of 30 hours, potentially coming from the Proxima Centauri B at the frequency of 982,002 MHz. How did the scientists conclude that? Answering this would take us another half an hour, so we'll quote the official statement. The shift in the frequency of the signal matched the orbital movement of Proxima Centauri B, and afterwards, the signal mysteriously vanished. The second attempt to establish connection in 2020 was unsuccessful, and in 2021 it was calculated that the probability of a species being both present in the nearest star system and able to produce radio communication was 10 to the minus 8, which means the likelihood of this signal being artificially created was extremely low. Additionally, since 2017, the astronomers closely watched for any activity around Proxima Centauri using radio telescope Atacama Large Millimeter Array. The red dwarf exhibits extraordinary activity, making coronal ejections, these so-called flares. The brightness of one of these flares increased 1,000-fold over 10 seconds, occurring over 2 minutes overall. Unfortunately, this fact signifies that Proxima Centauri B would be exposed to such a large dose of radiation that any life form would cease to exist. Considering that such flares are not uncommon for Proxima, the scientists theorized that any atmosphere that may have existed was destroyed and dispersed into space. And the last argument against Proxima B being habitable is the fact that the planet's cycle around its sun is only 5.12 Earth days. Sadly, this means the planet is too close to the star to be hospitable to life form as we know it. Even a cold star classified as red dwarf radiates too much heat to sustain water in its liquid form on the surface of the exoplanet. But the discoveries surrounding Proxima don't end there. Using the espresso spectrograph mounted on the VLT, the European Southern Observatory's Very Large Telescope, from 2020 to 2022, the scientists studied the transit of a mysterious, very small object which is estimated to be smaller than Earth. Eventually, a planet that came to be known as Proxima D was discovered using the method of measuring radial velocity. It's one of the most promising mini-Earths to be studied in the near future. The radius of the planet is estimated to be 0.8 of the Earth's radius, while its mass is twice as heavy as the mass of Mars. Scientists have yet to determine the viability of Proxima D as a habitable planet. But if the planet is uninhabitable, what use is that conclusion here on Earth? You've got to look at it from a wider perspective, taking the future into consideration. This discovery shows that our nearest neighboring star system is filled with interesting new worlds, accessible for further research and in-depth study. And even if the recently discovered world is not suitable for living, its very existence suggests there are plenty of other exoplanets beyond the current scope of what we can see. What do we mean when we talk about the current scope of discovery? As of today, we only have two main methods of searching for such exoplanets. The most commonly used is the transit method, whereupon the telescope observes the stars for extended periods of time to detect small but regular changes in their brightness. These changes signify that a planet moves along an orbit between us, the observers, and the star. The other more complex method is known as the Doppler spectroscopy, also known as radial velocity method or the wobble method. When two large celestial objects, such as a star and a planet, are interconnected by gravity, it doesn't look like one object spinning around another like a ball on a string. Instead, they both rotate around a mutual center of mass, also known as a barycenter. For example, the barycenter of the solar system is located just beyond the surface of the Sun. It makes the Sun to wobble in place, which in turn affects the amount of light that reaches our planet, an effect known as the Doppler shift. As the star gets further from us, the length of the light wave is increased, and as it's moving towards the observer, the length decreases. The astronomers can search for the regular Doppler shift occurrences to conclude the existence or absence of an exoplanet. These methods are fairly effective when we search for large exoplanets. A large celestial body blocks more starlight or causes a larger wobble. But discovering objects such as Proxima Centauri B is much more difficult. These numbers speak for themselves. As of today, only 36 planets out of 32,073 registered in the NASA Exoplanet Archive have a smaller mass than Earth. We only see the giants, which are usually less habitable than the compact mini-Earths. James Webb can determine the axial tilt of a planet, as well as its size relative to the size of the star. All of these are very important parameters, which we'll learn to apply in the future when the Space Telescope fully begins its mission in Lagrange Point L2 in the summer of 2022. And in the meantime, the telescope is being calibrated and prepared for the initial observation before uncovering the deepest secrets of our universe. When we talk about JWST, we're talking about the imminent future of studying exoplanets. But what if we look a little bit further? What awaits us in a more distant but already foreseeable future? Travel to these new worlds? Of course. Only in sci-fi spaceships as they move through space using hyperspace engines and warp drives. Breakthrough Starshot is an innovative project aimed at creating spaceships with a light sail, capable of reaching the Alpha Centauri system in 20 to 30 years by reaching the speed equal to 15 or 20% of the speed of light, thanks to super powerful lasers. This initiative attracted the attention of many space enthusiasts, including the founder of Facebook, Mark Zuckerberg. This project involves several stages, the first one of which is taking the base ship to the orbit, which will then get a number of smaller space equipment to orbit. The second stage is the most challenging, creating an entire forest of super powerful lasers located around the world to enable the constant acceleration of the equipment due to the Earth's rotation. Each piece of equipment 4 by 4 meters in size would be targeted by several lasers as powerful as 1 terawatt-hour. That's quite a lot, considering that the mining of all existing cryptocurrency takes 121 terawatt-hours every year. Altogether, the project founders, Yuri Milner and the late Stephen Hawking, planned to send 1,000 items of equipment to Alpha Centauri. And even then, the estimated cost of the project is suspiciously optimistic, only $5 to $10 billion. Considering the creation of James Webb taking $10 billion, the value of these projects to science is certainly comparable, if not the same. Just imagine, if we could send the probes to the stars that could become the penultimate stage in preparation for colonizing the faraway worlds, this would allow humanity to receive sufficient information about the worlds we may plan to visit in the near future. It could also answer that most existential question: how many worlds are there and how likely is the existence of life out there? Life as we know it. Not to mention the more exotic options like those science fiction authors love to invent. Finally, we want to discuss the potential non-standard life forms we might encounter on an exoplanet. Remember how mid-video we mentioned that Proxima Centauri is a rather temperamental star which flares up every 10 to 30 hours, showering the exoplanet Proxima B with abrasive rays, incredible amounts of radiation, and other treats? Well, these conditions are deadly to practically any life form on Earth. But the hope to encounter aliens lives on. Theoretically, life on Proxima Centauri B is possible, even taking into account the massive burst of radiation. Some living beings are able to hide from the deadly UV radiation. Aliens, or at least their single-cell forms, may exist under the planet's surface or deep in the water, taking cover in natural hiding spaces. Additionally, the process of UV absorption by proteins that's not been fully studied yet, which once again, in theory, allows us to speculate that organisms that possess these protective proteins can convert the UV radiation into biofluorescent radiation with a different wave frequency. Roughly speaking, we could dig down a few feet below the surface of Proxima B and discover an entire civilization of glowing biofluorescent creatures. Let's take Earth as an example. As you come down to the bottom of the ocean, you discover that some types of coral polyps contain fluorescent proteins, which are photoactivated when exposed to UV radiation in the long-wave A range at wavelengths of 315 to 40 nanometers, and in the blue regions of the spectrum at 420 to 700 nanometers, covering it into radiation with a longer wavelength. If there are organisms on Proxima B that could have adapted this method of radiation conversion, this planet could glow very brightly at certain wavelengths, possibly even within the visible spectrum. And such powerful glow would be possible to detect using the incredible tech such as James Webb. The possibilities presented by studying exoplanets are hard to overestimate because we're not just nearing the answer to one of the greatest questions in history. Are we alone in this universe? It also allows us to expand our horizons of development and distribution of humanity across the universe. It's up to us to answer these questions, and our only allies in conquering space are human perseverance and curiosity.